Today's video is on lesson 6.4, solving absolute value equations and inequalities. And so if we look at the absolute value, hopefully you remember that absolute value means how far a number is from 0 on the number line. So the absolute value of positive 5 is 5, but the absolute value of negative 5 is also equal to 5. So when we have a positive, the answer is positive, but when we have the negative, negative 5 is 5 units away from 0, and so by definition, the absolute value of negative 5 is positive 5, because that's how far away from 0 it is on the number line. The absolute value of negative 2 is 2, and the absolute value of positive 2 is also 2. So if I were to take the absolute value of an unknown, so I'm looking for the absolute value of x, and I know that the absolute value of x equals 8, that means that this number that's inside the absolute value sign would either be positive 8 or negative 8. Because if it's negative 8, the absolute value of negative 8 is still 8, and the absolute value of positive 8 is 8. So what I'm looking for is this part here that was in the absolute value sign. So x can be either positive or negative when it's inside of the absolute value sign. So the expression inside the absolute value sign can either be positive or negative, because once it comes out from that absolute value sign, it is a positive answer. Okay, so let's look at what this means. So if I'm looking for the expression, the absolute value of x minus 6, that means whatever this expression x minus 6 equals, when I take its absolute value, it has to equal 3. So this x minus 6 can either equal positive 3, because when I take it out of the absolute value sign, I get 3. But it could also equal negative 3. Again, because when I take the absolute value of negative 3, I get 3. So to solve this, I'm going to do x minus 6 equals 3, or this x minus 6 can equal negative 3, because when it comes out of the absolute value sign, it's positive. So I have two equations then that I can solve. So x can either equal 9 or x can equal 3. So if I put 9 in for x, 9 minus 6 is positive 3. The absolute value of positive 3 is 3. If I plug in 3 for x, I get 3 minus 6, which is negative 3. Negative 3, when I take its absolute value, also equals 3. So this check then down below here shows how I do that. I plug in each answer, and I get 3 equals 3 at the end. Okay. So then how am I going to do a problem such as this, where I have the absolute value of 2x minus 3, then I subtract 7, and that equals 4. Well, I don't want to set this equal to positive or negative 4. I first need to make it so it's just the absolute value sign on one side of the equal sign and just a number on the other side. So I'm going to add 7 to both sides first, which is going to give me the absolute value of 2x minus 3 equals 11. 7 plus 4 is 11. So now that this absolute value is the only thing on the left, I can then set up my two equations. 2x minus 3 equals 11, or 2x minus 3 equals negative 11. Then I add 3 to both sides here. I get 2x equals 14, divide by 2, and x equals 7. I add 3 on this right equation. I get 2x equals negative 8, and then x equals negative 4. Now if I plug in either negative 4 here, and I find its absolute value and I subtract 7, I get 4. Or if I plug in 7 here and then subtract 7 from that answer, I get negative 4, or positive 4, excuse me. So this is going to give me negative 11 in the absolute value, but then when it comes out of the absolute value sign, it's a positive. 11 minus 7 is 4. If I plug in 7, that still gives me 11. 11 minus 7 is still 4. Okay, so that's how I solve these with equations. But what happens if we have an inequality? And so far, we've been looking at inequalities in this chapter. So let me give you some general notes here. If we have less than or equal to, we then have an and inequality. So if you remember back to 6.3 video, we had those inequalities where we had like negative 2 is less than or equal to x, which is less than or equal to 0. That's an and. If we have the opposite of that, where we have the or, where we shade to the left or to the right, and we have this blank spot in between the two dots or circles, then that's an or statement. Okay? So this inequality right here, because the absolute value is greater than or equal to, that's an or because the absolute value is greater than. Okay? If I look at this next example, down here, the absolute value is less than or equal to. Because the absolute value is less than, that means it's an and statement. Okay? So here, I'm going to take x plus 2 is greater than 1. So I take that inequality, or x plus 2 is less than or equal to negative 1. So I flip the inequality sign, and I change that positive to a negative. Here with this problem, x minus 3 is less than or equal to 2, I have the statement, and then I flip the inequality sign, and I use the opposite of the number. Okay? So in both situations, doesn't matter if it's an or an and, both problems, I take exactly what I have in the original problem, and I take away the absolute value signs, or I take what I have in the original problem and I switch the inequality sign and make it a negative. And that happens in this example as well. Okay, so take the inequality as it is minus the absolute value signs, and then take it and flip the absolute value sign and flip the sign. And then I solve it the exact same way. Now, if you remember, greater than or less than is the or symbol. Less than or equal to. So greater than is or, less than is and. All right, so try a couple of these. We're going to start tomorrow with just some equations, and then we'll get into some inequalities. And so I would like you to try these 4 problems. The first 2 are equations. The second 2 are inequalities. This is less than, so that's going to be an and. This is greater than, so that's going to be an or. Try those problems tomorrow, and we'll go over them in class. Have a good night.